What is DevOps? I mean, there is a popular term telling that, it's a combination of developments plus operations, but what does it really mean? So, what does it really mean to me? Let's start with a very basic example. Now, any coding or anyone who's into coding would start with the idea of development of a code. Now, when I talk about development, then you have like different languages like Java, you have like C Sharp, PHP, HTML, Python today. So you need someone like a developer to begin your entire journey with. So a developer begins by developing his code on his laptop. So I'm a developer who's like beginning my journey. I'm like developing my code and I am basically going ahead writing my entire code from A to Z. And right now I know that, or I feel that my code is ready for testing, or my code is ready to be given to the end user. So what I do is like I say, okay, fine. Now it's the time to take my code to the next level. I will go ahead and give my code to someone called as a tester. Now, what is the work of a tester? It's to identify what are the issues with the code, or in popular terminology, it is called bugs in the code. So I am a tester right now. I have got the developer's work. The developer has spent like about 6 to 8 months in just developing the code, because they have been testing from their end. They have been looking at the code and they feel that, what, it's working absolutely fine, and they give it to the tester. Now tester is taking the code and tester is saying, okay, fine, let me test this out. And tester is like kind of testing it, and it's taken a month for him to test. And he's identified, let's say, a few issues within the code, a few basically issues that are in the code. And he says, what, hey developer, your application is giving some kind of an issues, because I see there are so many bugs here. Can you resolve it and again give it back to me? Meaning, now the tester is again giving the code to the developer. But at an organization level, I have promised my client to give the entire code within a year. So the developer has taken like 6 months, tester has taken like 1 month. Totally 7 months is done. I just have 5 months left to complete my entire code. Now the tester is pushing back on the developer and saying, okay, fine, your code has few issues. Can you please go ahead, fix it out? Tester takes it, sorry, the developer takes it. He now starts building his code again. He starts testing his code again. He says, okay, fine, this is fixed. Pushes it back to the developer. Sorry, pushes it back to the tester. Now tester takes, let's say, another 15 months. And in this tug of war, we have like again, spent about 2 months. So 9 months is gone. I have just 3 months now to deliver, or I have a deadline basically that is sitting on top of me. Now, can I give my code directly to the end user, or can I directly give my code to the client? Not really. I need someone, or I basically need someone to check my code in a real time environment. Now, who's that? It's called a business team, or very popularly, an operations team. Now, I have an operations team who's taking my code, who's going by my word, who's going by the word of my developer, and saying, okay, fine, this code is good. Let's test it out. Now, the operations guys, they are not technically very strong. They are not developers. So they just know how to test the code, or they just know how to run the code. So they are running the code and they're finding a few issues with the code right now. What is the operations team doing? Is operations team is coming back again to the developer and saying, what, the code what you have given me is not working in my laptop, or not working in my computer. Can you identify why this is? Now the developer says, what, the version which I developed, the version in which I developed my code, you probably have not installed that version in your laptop. Can you please install it? Meaning, what am I seeing out here is a lot of blockages. I, as a developer, know how to develop my code. I, as a developer, know how to basically write my code end to end, and I've like spent like about very good amount of time in giving a very good quality of code. I, as a tester, I have like tested this code. I know that there are no bugs, and I've like given to the operations, but the operations is coming back. Now we are again losing time, guys. We are losing a lot of time to deliver the software. But what is the irony of the situation, or what is the problem in the situation, is that we are trying to deliver the entire code in one bulk, aren't we? Because the developer is spending like about 6 to 8 months and he's developing the entire code, and the tester is doing it again. Then it's coming to the operations guy. It's taking like about 9 months to identify whether my code is good or not. This entire model is called waterfall model of development, meaning I am developing it, taking it to the next level, testing it, taking it to the next level. I have a operations guy who's like again testing it, again coming back. So there's a lot of tug of war here. So they said, okay, fine. It's not going to work out like this in a waterfall model, because here what's popularly happening is that we are losing a lot of time in each and every phase of the life cycle. And this entire thing that you see on my screen, which is development, testing, and the release of the code, all these three together are called SDLC, Software Development Life Cycle. This is the life cycle of any software that you take in the world. It begins with development, which is the primary thing, goes into a testing phase, and then goes into a code release phase. But I am losing a lot of time out here, which is why industry adopted to something called as an agile practice. Now, what happened in an agile practice is that they said, okay, fine, let's not deliver the entire code in one chunk. Let's not do that. Rather, let's break our code into small pieces, into small operationable pieces which can actually work, and then deliver those pieces to the customer or to the client, whoever I promised. Let's deliver it in bits and pieces. Let's have an agreement that in the first 3 months, I deliver something small. The next 3 months, I deliver something more. In the next 3 months, I'll deliver more. And in, let's say, a cycle of 1 year, I give the client a full operational code. It's just like this. You have an application called Ola, and the first time what Ola got released, I know that it only had cabs. Within, let's say, 6 months, it also came with hotels. Within the next, it also came with, let's say, food ordering. So this is called feature oriented development. I am not delivering my application at a go. I am cutting my application, or I'm breaking my application down into something called as features, and then delivering these features to the end user one at a time. Then is this okay? Like this model is okay? Yes, this model is okay. It's working out very fine, but there is something that is still missing on to the entire, entire fabric. What is it? Again, even in this model, my developer is developing, let's say in 1 month, he's giving it to tester is taking like 10 days, again going into the release, or again going to the business or the operations, they are again pushing back. There is this tug of war that is still there, even in a feature oriented development. And that's why they said, you know what, we need a team which accounts this, which can look like a developer and also help like an operations guy, and also test the code while the code is happening or while the code is getting developed. And that is where DevOps as a profession actually came into the picture. They said, okay, fine. DevOps now is an amalgamation of, or it's a combination of developers and operations guys who are coming together and forming one team. And that is where DevOps actually began. And this is what is a very popular diagram of what DevOps really looks like. Meaning, here the first phase is the build, meaning what build means is simply testing your code, or rather, if you start it even further, it is planning your code. It's like going to the customer, understanding what his requirement is, then getting your team, then understanding which language in which the code is being developed, then developing your code. And as and when your code is developed, even if it's a very small chunk of the code, test it out, go ahead, give it to the client, monitor it continuously, And according to what the monitoring says, again plan your code. So your software development lifecycle, which was a linear way or which had a linear texture, kind of right now has a cyclic texture out here. What do I mean by cyclic texture? Is that it is continuously evolving. You are planning based on what you have like monitored. So you're monitoring your software based on the client's feedback. You're again developing it. You're again building it. You're again testing it. You're again releasing it, deploying it, again monitoring it. And that monitoring is again coming back to, let's say, the operations team. The operations team is able to, let's say, pass on the feedback very well to the development team. And this is the exact reason, or basically what has this done to begin with is that it has improved the quality of the software development lifecycle. Improved in a way that you have a better quality of software today, and the delivery mechanism or the time to deliver the software has improved a lot. You are delivering the software in less than the promised time. This is because you have something called as a DevOps practice in place. And most importantly, why are companies adapting to it? Firstly, because it is agile. Secondly, it's automated. The entire process doesn't need a human intervention or doesn't need a lot of human intervention. So I am cutting down on a lot of cost. At the same time, I am improving the efficiency of my software development lifecycle. So that is the reason why you see a lot of companies today adapting to the DevOps practices. And when I talk really about DevOps practices, then I also spoke about companies that are adapting to it, right? And this is the average, or this is, let's say, the sum of all the averages of the companies that are hiring the DevOps engineers, and this is the average salaries that what the DevOps engineers are actually getting in. So you see all the top companies, like most of the top companies or most of the Fortune 500 companies, they need a DevOps engineer on their team. They need someone with a good amount of DevOps practice in their team. They need someone who knows what DevOps is and can implement it. Then when I say implement it, then what do you use to implement it? Or what is like used to really implement your DevOps practice? So out there in the market, when you type in DevOps, right, you will have a lot of tools, a lot of things that actually are available to you, and you can use a lot of them. You can choose and pick a lot of them and then implement things out. But why are we really looking at Azure DevOps as that? Or why are we looking at Azure DevOps as such? Is because we are learning a cloud called Azure, and Azure DevOps is the native version of DevOps for Microsoft. So Azure DevOps is a tool, a technology that you can use to implement DevOps practices. Is Azure DevOps the only thing that is available out there in the market? Of course not. But why should you go for Azure DevOps? Because it integrates very well with Azure. It has the same SLA what Azure has, and you kind of get a better support to the other products on the market. Like if you were to go with a cloud like AWS, which does not have, let's say, its own DevOps practice, then you'll have to basically rely upon other open source tools. Like there are a lot of open source tools available in the market today, which do not promise a great SLA. So if you're a company who is like really looking into, or who is like really, who really needs, a good amount of time to deliver the software and good amount of time, good amount of SLA basically being promised, then they rely on such a product like Azure DevOps. And the journey of Azure DevOps is something like this. Started off in 2011 as something called a VSO. It's called Visual Studio Online. And then basically went into something called VSTS, Visual Studio Team Server. And now finally it is taking a shape called Azure DevOps. So you hear people using all the terminologies. Like some people, they call it as VSTS, some people call it as ADO, a very less amount of people call it VSO, and popularly called as Azure DevOps as such. And what makes it standalone? Like, there are a lot of products, right? So what makes this guy standalone? Thing is, you do not have to install anything for Azure DevOps. Let's say for Jenkins, yes, you need to install something. For any product out there, you need to install some basic thing out. Azure DevOps as such is a service in itself that can be consumed over the internet. All you need is a laptop and a good connection of the internet, and you can start consuming this particular service. You do not have to go ahead and install something. Same with Azure. If you want to use Azure, all you need to do is like have a laptop, have a connection, you're good to go. You do not have to really go ahead and install something out there. You are all set, and you can just go ahead and work from any corner of the world. You do not really have to basically have any pre-installed softwares on your laptop or on your computer to go ahead and interact with these softwares. So this makes it more user friendly, and it has a very good graphical user interface, so it makes things easy to understand. This is why Azure DevOps is kind of taking a very big share of the market today. So